converting a repeating decimal to a fraction. I want to convert this repeating decimal into a fraction. And notice this one has actually a mixed number. So the first thing I'm going to do is set aside the whole number. This is going to make the work much, much easier to me. I know it's going to be a mixed number, 4 and some fraction. So then, my next step is to write an equation and repeat the repeat once. I'll do that all in one step. So my first thing is an equation. X equals, and I set aside the 4, because I already took care of that. So 0.3, the 8 is repeating, so 8, repeat it once, 8, dot, dot, dot. Remember, the 8 is repeating. My next step now is to do an equivalent equation, and I'm going to move the decimal to after the repeat. So I want to move my decimal here to after the repeat. So I want the new decimal to go after the repeat. So it was, the 8 is repeating, I'm moving it to just one place after the repeat. Well, how many times did I have to move that? I had to move it twice. Since I'm moving it twice and I need an equivalent equation, I need to multiply this x times a power of 10. So I'm going to multiply that by 100. So 100 times x will make it still equivalent because I moved my decimal twice. So this is now 38.8 dot, dot, dot. Remember, this is still repeating. It goes on and on forever. And this equation here is equivalent to this equation here. Now I need to write another equation. So in step number 4, I'm going to write another equivalent equation, but this time I'm going to move the decimal to before the repeat. So my decimal was here in my original equation, and I want it to go before the repeat. So I want it to be here. So how many times did I have to move the decimal this time? Just once. Well, what power of 10 would I multiply by x to get an equivalent equation? Just by 10. So that's 1, 0, moved the decimal once. 10x equals, now when my decimal is here, this is just 3.8. So 3.8, again, still repeating, dot, dot, dot. In my last step here, or fifth step, I'm going to subtract. So I'm going to subtract these two equations. This one's done. I'm done with that one. I'm going to subtract these two equations. 100x minus 10x is 90x equals, well here, my repeats canceled each other out. That was my goal. And I have 38 minus 3, that is 35. And now I'm ready to solve an equation with no repeats for x. How do I do that? These are multiplied. Opposite is divide. Divide by 90. X equals 35 over 90. And now my last step then is to simplify if necessary. Well, it is necessary. These can both be divided by 5. And 35 divided by 5 is 7. 90 divided by 5 is 18. Do the work here if necessary. I've done this enough, I know that. Do the work off to the side if you need to. But hey, I'm not done, because remember, I was not solving 0.38 repeating. I was solving 4.3 with the 8 repeating. So my 7/18 needs to go back into my mixed number, and I get 4 and 7/18. I can do the same thing here with this repeating decimal. So I'm going to set aside the whole number. Well, there's not one. Write an equation and repeat the repeat once. X equals 0. What's repeating? 39. So 39. 39. I'm going to move the decimal to after the repeat. After the repeat, well, the 39 is what's repeating. I had to move it twice. So that is 100x equals 39.39. Next step, equivalent equation, move the decimal to before the repeat. Well, hey, look, I don't have to move it at all. It's already before the repeat since everything is repeating. So I'm just going to write that original equation. X equals 0.39. Remember, these were repeating. I'll put those dot, dot, dots there. And then, in step 5, subtract my equations. 100x minus 1x is 99x. Equals, look, repeats, parts, cancel each other out. My decimals are lined up. 39 minus 0. Nice math. I like that kind of math. And then, to get rid of my 99, I divide by 99. X equals 39 over 99. What can I divide both of these by? I can divide them both by 3. 39 divided by 3 is 13. 99 divided by 3 is 33. Did I have a whole number? No. So, oops, my pen's not working. So, x equals 13 divided by, or 13 over 33, 0.39 repeating is the same thing as 13 over 33.